Hi, I'm Tyga Anderson, and I'll be going over spectral analysis in this episode. In spectral analysis, we aim to get a low frequency, high frequency ratio. A low frequency ratio is between 0.04 and 0.15 Hz, and a high frequency ratio is between 0.15 and 4 Hz. When the ratio is lower, we assume parasympathetic dominance, and when the ratio is higher, we assume sympathetic dominance. We're going to continue working on the same lab chart file and the same recording that we worked on to do our SKNA analysis. And so first we're going to go up to the top where it says Window. There's going to be another tab here called Spectrum View. So we're going to select Spectrum View. And the first thing we want to do is in Display Channels, we want to make sure that we are working in the integrated SKNA channel, and we want to deselect the ECG channel. Once we've done that, we want to go to Settings to the left, and FFT size should be 32K, and window overlap should be 93.75%. Mode should be power density, and we can close. Now all our settings are made. We want to draw our attention to the left-hand axis here. Sometimes the scale is different, so sometimes it's a lot larger of a scale, but we want to make sure that we zoom in our scale to around here, because if you remember, the low frequency ranges from 0.04 to 0.15, and the high frequency ranges from 0.15 to 0.4. So we don't really care about anything above 0.4 when we're visualizing the spectral analysis. You'll notice here around 9:49 a.m. that this patient had a bright spot, and this bright spot means that there is high power at this area, and you notice that this area is below 0.15, roughly below 0.15. Therefore, there was high power in the low frequency domain, and we can assume a high low frequency high frequency ratio, and therefore sympathetic dominance. If you see a bright spot above here and no bright spot down here, we would assume the opposite, and we would assume parasympathetic dominance. So another way to visualize, for example, if we want to visualize this minute from 9:49 a.m. to 9:50 a.m., another way to visualize is to use this top area. You'll notice instead of hertz on the y-axis, we have hertz on the x-axis now. And so similarly, we want to make sure we are zoomed right in, because we only care about 0.4 or 0.04 to 0.4. So another thing I'll do here, because this is a crazy line that we see, we want to select this drop down and auto scale. And this also visualizes kind of what we're seeing here with high power in the low frequency domain right here. High power in the low frequency domain. After we're done here, we can go up to the top data pad and go to our view data pad option. So last time we set up these 4 columns in data pad view of the 4 pieces of data that we want to extract from this recording. We had date, we had time, we had average SKNA, and we have heart rate. Now we're going to add 2 more columns to this. The first column is going to be our low frequency data. So to get this, we're going to go all the way down to spectrum. We're going to look for total power. We're going to go down here to integrated SKNA. With our options, we're going to look at our lower frequency and our higher frequency limits. And as you recall, low frequency is 0.04 to 0.15. The format, we'll select scientific because it tends to be a low number. And we're going to select OK. Now, with our next column, we'll do the same thing but for higher frequency. So we're going to go down to spectrum. We'll go to total power. We'll select from our integrated SKNA channel. We'll go to options and we'll select from 0.15 to 0.4 for our high frequency limits. And we'll also select scientific because it tends to be a low number. So now that we've created our low frequency and our high frequency columns, we can go back to our chart view, which is the same from last time, and we'll go back up to our data pad to our multiple add to data pad. From here, since we've already cut off the beginning and the end noise of the file, we can go ahead and step through the entire file. And instead of 1 second, we should make sure it's on 1 minute. So now we can go back up to the top left corner to data pad view, and we can explore our data. Just like last time, I'm going to copy all this data, and then I'll go paste it into my Excel sheet. So here's our Excel sheet. I'm going to go ahead and paste our data, and then like last time I'm going to change the headings a little bit so as to not get confused. This first row we can delete because there's an error in calculating the average heart rate. And we'll make sure we're clear about our labels here. This one is low frequency, this one is high frequency. And something I also notice is that the time is not in the time format. So let's fix that really quickly. And then let's go ahead and do a low frequency, high frequency ratio. And we can select equals the cell that has the low frequency divided by the cell that has the high frequency. And then a good trick is to double click on the bottom right corner to get our values. And you notice this in scientific, but because it's a ratio of similar numbers, we can turn this into general and it will look a little bit better. I'm going to scroll down all the way to the bottom. And I'm going to get rid of all of this extra calculated field that we don't need. Good. Now, we already looked through the entire recording for artifact last time, so we can go ahead and use that same data where we stepped through the entire file and identified which segments are noise. Now we can go ahead and highlight all our data, go to Insert, Pivot Table, just like last time, select Existing Worksheet and find an open area in your worksheet. and then we can go ahead and start constructing our pivot table. We'll have date in the rows, we'll have average SKNA in the values, we'll have heart rate in the values, and now we'll have an additional low frequency, high frequency ratio in the values. Remember, we want all of this to be average instead of sum, so we're going to select field value settings or value field settings and select average. So in the drop down we select value field settings and average. I also want to drag noise equals 1 to filters and make sure we're only analyzing clean recording by deselecting 1. I'm going to clean this up a little bit, and here we have it. With this recording and this patient, we can see that the low frequency high frequency ratio rose from June 1st to June 2nd, from 0.62 to 0.70, indicating sympathetic dominance on the second day of the recording compared to the first. I hope you found this video helpful in using LabChart to do spectral analysis.